So one of the common questions when people hear about microservices is, okay, well, I have these existing applications which are monolithic and I want to migrate to microservices. What's the best way to do that? So we'll go through how Atlassian did that. So Atlassian's a tool vendor. We saw them with the SourceD case study. They make Jira, Stash, Bamboo, Confluence is a wiki, and other things. Um, their applications are currently monolithic, and the goal is to move the applications to a more modular microservice architecture. So this monolithic is a common way that startups evolve. So the first goal of a startup is to get your code working, and then it kind of grows. And when you are successful, then you can think about, okay, how do I make this last for a long time as opposed to just dealing with fires. And that's the stage that Atlassian at least was in a couple years ago. So they create a three-layer architecture. There's the application, there's a utility, and there's a platform. And each layer is architected and deployed independently. And the goal is to have microservices also deployed independently within each layer. And so they did this in parallel with a platform that they were developing. And so they would have a microservice. This is the executable view of a deployed microservice. So they would have a microservice existing in two availability zones. Um, the last ELB is an AWS service. It's the Elastic load load balancer, and it scales for you. I'm sorry, yeah, it's the Elastic Beanstalk. It scales for you. So it's a deployment tool and a scalable tool, and that would work for the services. They would deploy it using ELB, and then as the demand grows, it scales, and as the demand shrinks, it unscales. And it does this in two different availability zones. They also use Elasticsearch, which is AWS's search facility, and they use the same Elastic Beanstalk for Elasticsearch. And Elasticsearch searches a database. So that's what the two databases are. And the particular microservice that they started, well, wasn't they started with several, but one of them is Blobstore. It's the one our case study is about. And so what it does is it stores binary data for future retrieval, and it's used by multiple different applications. So again, this is a common theme when you're migrating to microservices is you look at your existing applications, you say, okay, what are some of the common features that exist in duplicate in these applications? Let me factor them out and create a microservice that will handle that. In this case, it's Blobstore. And so in their current data centers, they have application instances which are going to have client plugins to communicate with Blobstore in the cloud in AWS. So they're doing several things in parallel. They are creating Blobstore, they're creating a platform on which the microservices will run, and they're migrating their applications to the cloud. So every time you add another, they're doing another thing. It's sort of like juggling an additional ball. It gets more and more complicated. So what does Blobstore do? Well, it stores the data in AWS in several regions, or at least several availability zones, and that's for business continuity, as we discussed. The blobs that are sent to Blobstore are data, so just binary data and a logical key. And the data is stored in the on the database in two different ways. Well, it's stored in one way, but you can access it and stored in two different ways. You can access by a content hash. So I hash the content, and that will give me a pointer to the data, or it's hashed by a context logical key. And you can retrieve it either from the application, either by the logical key or the content hash. and they store the key mappings uh, in a database. So you would have a content hash. A hash is a fixed length. You look that fixed length up in a key value database, and it gives you the actual address of where to go. And the other interesting feature of Blobstore is that data is always appended. It's never deleted or overwritten. And so backing up or finding old versions of whatever it is that you're stored is automatic. You don't have to worry about it having been overwritten, and you don't have to worry about it being deleted. You just need the content hash. So the Blobstore is 2,500 lines of Scala. So Scala is a functional programming language, and it was developed by a small team. And as I said, it was developed while the platform was evolving. So if you look at the deployment, I don't know if you can read this, but if you look at the deployment pipeline, the top part are features of Blobstore, and those are tested, and then they're merged into the main part of Blobstore. This is over here in the picture. And then that's built and tested, and then it's released. And so then there's a deploy to a local people, so for deployed to the domain, and then it's deployed to the for applications, and then it's deployed to a staging, and then it's finally deployed to production. So this is their pipeline. Slightly different stages than the ones we've talked about. They do have a staging thing, but there's one where applications, since Blobstore is a utility, there's one where applications would be used to test it. The other side of it are the applications. So they would uh, uh, develop their application, they would test it with the new version of Blobstore, and then they would release it. So they have their own life cycle and their own set of stages. So the summary is that their approach to migration to microservice architecture is refactoring existing applications and finding services that are common, and that's a typical pattern for people that are migrating to microservices. Blobstore is a particular storage management module, and that's one of the first services that they're migrating to microservice.